operation. So here if I am going to tell A of top, this will return, if I am going to tell return A of top, this will say the value that is pointed by the top of the stack. So these are the base and simple operations that we can do with the stack, like peak, is full, is empty. Now let us see how to push and how to pop an element using an array. So looking at the push operation, as we said, the push operation is nothing but inserting some element. So this is an insert operation. So inserting an element into an array is, as we say, this is an array implementation. So we have some set of fixed sized array as A. Let us take this as A, and we do have one pointer called top, and this top is going to point to -1 initially, and this is going to have the index from 0 to 4 as we tell n equal to 5. We can hold 5 element. In order to do the push operation, first we are going to check whether the stack is empty. So initially we are going to check for is full. So let us check whether it is full, because if it is full we cannot do insertion operation. So checking for full. If there is a space, so if space available. So if space is available, then we can start doing the insertion operation. How we are going to do the insertion operation? We are supposed to increment the value of top. Top has to point to 0. So top has to move from -1 to 0, and then the element can be inserted. So these are the two steps. So in order to do this, we are going to increment the top by 1. So top plus 1, and then we are going to insert the element into the stack having with A of top equal to element. So that the next time again the top value will be incremented to 1 and then the element 20 is inserted. So this goes on until you are seeing is full. So looking into the push operation, basically we are supposed to check whether it is full, because if it is full we cannot do the insertion operation. So check for full. If space is available, just increment the top value and insert the element into the stack. Speaking about the pop operation. So pop operation is nothing but deletion operation. We are going to have some elements inside the stack and the elements can be deleted. So let us imagine we have a stack here as A, and now the pointer here is pointing to 3. So this is a top, and we have some set of elements like 30, 40, 20, 10, right? So now we are going to do the deletion operation. But before doing the deletion operation, we are supposed to check whether it is empty. Check is empty. For insertion we have checked is full. For deletion we are supposed to check for is empty, because if there is no element we cannot do the deletion operation. So we are going to check is empty. So if element is present, if it is not empty, so we can just decrement this top. So top can be decremented. If you are going to bring the top down, then automatically this element will be deleted. So we are supposed to do a very simple step. If not empty, then top is decremented, top -1. So just by decrementing the top, this 30 will be removed. It is nothing but when you are going to display something. So when you are going to display something, you will be displaying from 0 to top. So automatically 30 will be removed. So this is how pop operation will be carried out. So to summarize, In this video, we were discussing about the linear data structure starting with the Stack ADT, where we said Stack is a linear data structure which works with the principle of last in first. The element which is inserted last will be deleted first, and this has a top pointer. Only using the top pointer every operation can be done. Looking into the operations, push operation, pop operation, which is nothing but insert and delete, peek, is empty, is full, traverse, search, sort, all sorts of operations can be carried out, and the implementation can be done either using an array or using a linked list. And looking into the insert is empty and is full. So we said we are going to check whether top is -1. If it is -1, it is empty. If top is n-1, then it is full. And peek is something but top of the stack, which is going to return the topmost element. And speaking about the push, in order to insert the element, we are going to check whether it is full. If it is full, we cannot do the insertion. If there is space, then top is incremented and elements are added. And for pop, we are going to check empty. If empty, then deletion cannot be performed. If not, if it is not empty, then top is decremented. And traversing is nothing but when we go for traversing or displaying the stack values, we are going to have just a for loop from I equal to 0, I is less than equal to top, I plus plus, and just a print statement of A of I. So this will display the element. So that's with the stack implementation having with an array concept. In the next video, we'll be discussing the stack with linked list implementation. Thank you.